Hi, my name is Ian Kawirasuke, and today I'll be teaching characteristic of polynomial functions. Table of content. So in this unit, we will include degree, leading coefficient, domain and range, and behavior, turning points, and zero of the function. So first, we'll get into the polynomial basic function of the equation. So we use the term f of x, and as you can see, the exponent is n, and it has to be positive and whole number. This is a must. And there will be obviously a operator and constant as well, which is real number. So a would an, a0, a1, a0, they all are the terms, and this would make a polynomial function equation. Degree. Degree is the highest power in the polynomial expression. So for example, in order to find degree of a polynomial function, we would have to look at the highest number in the power. So for example, x power of 2 plus x minus 5, the degree will be 2. And in this case, there's 2 degrees, and we would choose this degree because it's higher than number 2. So for this one, there's a even invisible number 1 here, so the degree is still 1, and it's not 0. Last example, 3x power of 2 minus 7 plus 4x power of 4. This one, we would choose the degree 4 because it is the highest. So there's two types, odd and even degree. In order to identify odd degree, we have to look at the numbers and see whether if it's odd or even. So for this example, 2 power of x power of 2 plus x power of 5 minus 5, the highest degree is 5, so it is an odd function. In this case, even degree, in order to find even degree, we would have to look at the highest degree and see if it's even number or odd number. So in this case, it will be 6, and it is even degree. Domain and range. So polynomial function has a domain of x minus x is minus infinity and infinity. And even degree function would have bounded range. On the other hand, odd degree function would have a range of y is negative infinity and infinity. So domain is all real numbers in polynomial function, and range can be real numbers or have upper or lower bound. So for example, x power of 2 plus x minus 5, the domain is real number, as I said, and range will be real number, and y bigger or equals to negative 21 over 4. In this case, 2x power of 3 plus 3x power of 2 minus 3, we would have a real number domain and real number y range. This would be the same as well. And the last example, we would have a different domain range for this, whereas y is real number and can be also bigger or equals to minus 7. Symmetry. So there's two types of symmetry, even function symmetry and odd function symmetry. For even function symmetry, it is if it's all the exponent in the polynomial function is even number, it is called an even function. And visually speaking here, we can see that the graph is mirrored opposite mirrored, so it is also can be seen as f minus x is equals to f of x. So it has a symmetry over the y-axis. You can see it is identical in both sides. An example would be f3 equals to f minus 3, odd function. This is totally the opposite of even function symmetry, and we can know this by if all the exponents in the polynomial is odd numbers, it is called an odd function. So we would have a symmetry about the origin here. So f minus x is equals to minus f of x. So it is still identical, but then the graph, visually speaking, is flipped over and upside down. example could be f3 equals 6. And this can be also seen as f minus 3 equals minus 6. And behavior. And behavior is pretty straightforward, where we all have to look as degree and the leading coefficient of it. So when we have a even degree and we have a leading coefficient of positive, we would have an end behavior of x, it becomes plus infinity, y becomes plus infinity, and as x becomes minus infinity, y will become plus infinity. So for this, we can see the graph here. When x becomes infinity plus, y would grow bigger also. When x goes to the minus side, y would still grow up also. So that's what it meant by the end behavior. When you have even degree and negative leading coefficient, we will have a x becomes plus infinity, y becomes minus infinity, x becomes minus infinity, y will have minus infinity as well. For odd degree and positive leading coefficient, we will have a graph something like this as shape, and it rises to the right and falls to the left. As x becomes plus infinity, y will become plus infinity as well. As x becomes minus infinity, y will become minus infinity. This is easy to remember. For odd degree and negative leading coefficient, we would have this end behavior. X becomes plus infinity, y becomes negative infinity. As x becomes negative infinity, y would have plus infinity. So this one, we can easily remember the table and know the end behavior. Leading coefficient. Leading coefficient is the number written in front of the variable with the largest exponent. So like I said previously in here, this one is the leading coefficient, and it is the term with the highest degree. So we have positive and negative leading coefficient. When we have positive leading coefficient, the graph will look like upwards, like this one. And when we have negative coefficient, leading coefficient, we will have a downwards graph. So this is a visual example. As you can see, when we have negative coefficient, it's down, and positive, it's up. Absolute and local maximum or minimum. Absolute maximum or minimum is the point of a function attained its highest or lowest value in its domain. And local maximum or minimum point is the function attained its highest or lowest value in its one interval. So by this I mean when point is lower than the points surrounding it. So here would be the graph visual speaking. As you can see, global maximum is also known as the absolute maximum or minimum point here. So it's the highest or lowest. And local minimum or maximum is the function it's attained highest or lowest value in its one interval. Stationary points. Stationary point is a point where the slope of the function, which is y equals f of x, is 0 when it becomes 0. As you can see the graphs here, it is all 0. The global minimum, the local maximum, it is everything 0. That's pretty straightforward. And turning points. It is the point where the slope of the function changes signs at the stationary point. It can be also called local maximum or local minimum. So it is the point right after when it changes direction in the graph. So in order to find how many turning points are there in one equation, we can use the formula degree n minus 1. So a polynomial of a degree n will have n minus 1 turning points. For example, x power of 2 minus 2x plus 4x power of 3. This one we would take the highest degree, number 3, and minus 1. Degree 3 minus 1 it's 2, so there will be 2 turning points. This will be the graph example here. As you can see, there's 2 turning points. Point of inflection. So inflection points are points where the function changes its concavity. Meaning by this is that changing from being concave up or to being concave down. as you can see in this graph, it is concave upwards and concave downwards. And this would be the inflection point right here. Order of zero. So order of zero is also known as the x-intercepts. And it is when a polynomial function has a factor of x minus a power of n. N means how many times it's being repeated in the function. And x equals a, which is a zero order of n. So it will be easier for me to give example. For this, f of x equals x minus 1, x minus 2, x minus 3. This one we would say that order of 1 zeros, x minus 1, 2, 3. For this, f of x equals x minus 1, power of 2, x minus 2. This is simple also, where we just have to say 1 order of 1, 0, x equals 2, and 1 order of 2, x equals 1. And in this case, x minus 9 power of 3, x minus 6 power of 5. This one, all we have to just say is 1 order of 3, x minus equals 9, and 1 order of 5, x equals 6. So the behavior and order of 0 of it. Linear factor, which is we will have curve passes through the x-axis and it will have a linear shape. Squared factor will have curve is a tangent to the x-axis and it will have a parabolic shape. Cubed factor will have curve is a tangent to x-axis and passes through, and it would have a cubic shape. So these are the example. This is linear, and the second one is parabolic. Third one is cubic. Thank you.